Hey everybody, welcome to CS202 Assignment 3, and the theme of the assignment will be Pokemon Yellow. Now, you might have played these games or heard about these games back in the day, and these were sort of popular Game Boy games. So when I was younger, I had Pokemon Blue, but I wanted to use Pokemon Yellow theme because, well, Pikachu is the rather more well-known Pokemon character in the Pokemon world, I guess you can say. So, in this game, we're going to basically simulate a battle between two Pokemon. Now, if you ever played the game or ever just maybe you've seen somebody else play it, you know how this game works. It's a turn-based battle game, so you have you against another trainer, and you guys select Pokemon to battle each other against. And typically, you choose Pokemon that attacks the other Pokemon's weaknesses. So typically, if the opponent uses a rock or a fire Pokemon, you want to go with the water Pokemon to be able to counteract and to be able to defeat that enemy faster and so forth. So in this version of the of our game for this program, we're not going to be able to do that because that would involve using virtual functions and abstract classes and so forth that we have not quite gotten there yet in this semester. So in this game, we're going to really just have just a battle between two Pikachus, and hence Pokemon Yellow, because that was a Pikachu themed game. So that's essentially what we're doing. And remember, in Pokemon, you have whenever you have two Pokemon battling each other, it's turn-based, and each sort of opponent one, opponent two take turns, and then they just simply apply or they choose one of the attacks that a Pokemon has against their opponent. So you typically have four attacks, and then you of course can choose whichever attack you want to use for this current round for your turn in this match. Now each attack could range from attacking, or it could be attack that increases your defenses and so forth. But to simplify this program a bit, we'll have it where our four attacks will just be regular attacks, no increasing defenses, doing anything else like that. So each attack has a power, how much power it can inflict on your opponent. Also, each move you have an amount, so you can't have a limited number of moves. So each move has a limit for how many times you can use it in the current battle. And there's also an accuracy amount, which tells you how likely this move is going to land on the opponent. Typically, you have it where a very powerful move has a lower accuracy, and a not so powerful move has a very high accuracy. So that's usually how the game is played. So that's sort of the just the explanation for this assignment. Let's go ahead and now discuss the classes we're going to need to implement in order to implement our games. Let's go ahead and get to it. So our first class is going to be this attack move. As you can see, it's a pretty simple class, and it's really just going to be like a struct in a sense, because every member is public. But I wanted to use a class, not a struct, just so it's consistent for everything we're going to use in this assignment. So this attack move is going to simply store all the attributes for an attack. So for the Pikachu class that we'll discuss later on, we're going to maintain an array of attack move objects. And each attack move has these four fields. So we have just a name of the attack, the amount, which means how many times the attack can be used in one battle, the power, or the damage that it would inflict on the opponent, and then the accuracy, which tells you how likely this attack is going to work. So that's going to be our first class, attack move. Okay, so our next class is going to be the Pokemon class. So pretty much this is going to be our base class, or we can treat this like an abstract class, but it's not going to be an actual abstract class. But if we were to implement polymorphism, this would be an abstract class. So you can see that Pikachu is a Pokemon. So we're going to use this Pokemon class to create the Pikachu class. Let's go ahead and go over all the members. So as mentioned, yes, we're going to have an attack move array inside of this class Pokemon. But we're going to inherit this class into Pikachu, so Pikachu is going to indirectly have a list of attacks. So I said a sec earlier, I was saying Pikachu will have an array of moves. Well, Pokemon actually has it, but we're going to inherit this to Pikachu. So we simply have this array of 4 moves. We have this constant max moves variable set to 4. We're going to have an array of size 4, so 4 moves. And remember, each move contains the fields, the power, the name, the accuracy, and the amount. So we just have that in this array. This variable right here, amount of moves, is going to store how many moves we have so far. So we could have a case where a Pokemon could have less than 4 moves. So we have a not a very well trained or not a very evolved Pokemon, you may only have 1 or 2 moves sometimes. Now, in our game, we're going to have it where the 2 Pikachus that will battle each other will have 4 moves, but we have this variable because sometimes, we could have less than 4. So just to be, just to implement that potential scenario, but we'll never have less than 4 anyway, but there we are. Then we have defense. So this defense amount is going to simply tell us how much damage this Pokemon can absorb. So if the defense is 0, then pretty much any attack will be relatively super effective on this Pokemon. The defense is going to reduce the amount of damage that's inflicted on the Pokemon when the other Pokemon uses some move or attack on it. So defense is going to just be used to reduce the amount of damage inflicted on the Pokemon. And HP is just the health for the Pokemon. So those are the fields right there. Of course, max moves is your constant. So this header file will be given to you. So we have our 2 constructors. I have everything documented here in the PDF. And of course, you can read through that. But I'm just going to explain it here in the video. We have our 2 constructors that are written for you. We just simply set the fields. So default constructor will set all zeros. And our parameterized constructor sets the health, defense, and amount of moves accordingly. So this is just a more fancier way to initialize your instance variables. It's going to simply go initialize HP with H, defense with the value of D, and amount moves will be set to 0. Now, the add move function, we're going to insert sort of an attack move into our moves array. So this amount moves variable that we have right there, that's going to be like your counter. Essentially, it's going to be 0. So whatever this parameter object we have right there, we're going to assign it into position amount of moves of this moves array, and then increment the moves counter by 1. So we're simply going to 1 by 1 add a move. Now, we return true if the move was successfully added, so we didn't max out. So let's say we have only 1 move so far, then we insert the this parameter value into index 1 and then increment it by 1, return true. Now let's say if max moves equals amount of moves, it's equal, we can't add a 5th move, so we just don't do anything but return false. That says that we were not able to add this move. So we're going to be using this to sort of add the moves to our Pikachu characters when we read stuff from our file. Now, decrement HP, this is pretty simple. We pass in some amount, we're going to decrement the HP value with whatever is passed into this parameter. So let's say we have HP of 50, we pass in 5, we're going to subtract 5 from the HP. And of course, if this amount creates it where this health is less than 0, then assign it to 0. So let's say if we have a current health of 5, and we pass in the value 10 to this decrement HP function, then we'll set the HP to be 0. So we won't store negatives, we just set the value 0 if this decrementing amount would result in the HP to be negative. The move used function, well, this function takes in some index, and we map it to a position of our moves array, and we decrement the amount, which tells you that this move has been used once, so we want to reduce it by 1, so that way we just sort of keep track of how many times we use that move. So this function is pretty simple. Pass in the index, map it to a position of its moves array, dot amount minus minus. And then move usable, this function returns true or false if the move is usable. So in other words, we pass in some integer, some index into the, and we retrieve the moves at this index. If the amount is 0, return false, because the move is not usable. If this index is beyond the bounds of the array, well then of course return false then too, because this move is not even a valid move. So either if the index is out of bounds, or if the index, we assign this index, we use moves at this index. If the amount is 0, return false. Otherwise, return true, which means that whatever attack we want to use is usable. So we're going to use this in main to verify if the attack can be used before we apply the attack on the opponent. Then these getter functions right here, well, this get HP, self-explanatory, returns the HP field, get defense, returns defense, and then get move is going to just be passing some integer, some index. It returns this moves at this index. Now, display HUD is a little bit of a busier function. This function is going to simply just output the health of the Pokemon and then all of their attacks. Let me go ahead and show you here in the PDF what this function display HUD does. Essentially this. It outputs this and only this. It outputs basically the health and the value of the health, and outputs the actual move. So I is your index, name, amount, power, and accuracy. Now, I use IO manip to display this output nicely. However, on code grade, I'm not going to use a white space checker. So you don't have to get it to look exactly like this, but I have it like this so it's easy, you know, to be able for you to look at the output and make sense of it. Now, this row of dashes, I think in a PDF I give it to you, is actually 35 dashes right there. So you don't have to even count that, just 35 is also in a PDF as well. So essentially, you want to output somewhat like this. You want to output just the health and then their moves somewhat nicely. So you want to output each move on a line by itself. And the spacing between them is not really important. Just as long as there's some space between them, that's all you have to worry about with this display HUD function. Okay, so let's go ahead and now talk about we have 2 more classes to discuss. Let's go ahead and discuss those ones. Okay, so now we're going to talk about our random number generator class. So in C++, we have this rand function, which I actually described this right here in the PDF. We have this rand function, but there's a problem with it as in, well, if you use maybe Windows or Linux or Mac, between different operating systems, the possibility of the random number generator might be a little bit different for each system. Now, of course, if you upload the code grade, no matter, so let's say if on your Mac, the numbers come out different, on code grade it will all come out the same. But the problem is that it might make it a little bit hard to test your program locally. So I provided you with this class right here, and you just simply have to include R&D into your other classes. You don't have to actually worry about this. It's already given to you. So you have to essentially create an object of R&D type, and then that object dot generate random number. That's going to be your rand function. Of course, whatever it returns, you can mod it by some value to get a number between 0 and something. So if you take this generator, mod it by 100, it'll give you a number between 0 and 99. So I looked this class, this function up. So I just sort of looked it up. So I didn't make this up on my own. I used code that was available online, but the purpose was that way we all have the same random number generator. And we're going to be using this in our Pikachu class because we're going to have to use this random number generator to be able to sort of determine if the accuracy, whatever the accuracy number is, if the move is going to land or miss on the opponent. Remember in Pokemon Stadium or Pokemon on the Game Boy, certain moves, they miss sometimes. So we're going to use this along with our accuracy value to be able to compute whether a move is going to hit or not. So let's go ahead and now discuss our final class, the Pikachu class. Okay, so our final class, the Pikachu class. Now, we include several headers in this file because we need to have Pokemon defined, RND, and attack move. Now, you might have also noticed, I didn't mention this earlier, that we have these header guards right here. And the purpose of doing that is sometimes if we define the class multiple times, so for example, we have Pokemon header file, it's included in the Pokemon implementation file. And we also have to include Pokemon.h into the Pikachu file, and then we include Pokemon and a Pikachu and other files, which could end up redefining a class in different files. So to avoid having that redefinition and causing this error, we use header guards to avoid that. So it's not going to allow the class to get defined multiple times, which could happen by just including through multiple files. So that's what those are. But you're not going to have to worry about touching the header files. Those are given to you. And of course, I do give you guys a skeleton code of the implementation files. So, you don't have to worry about getting things to compile because it's all set up. You have to simply just write the function codes for each class. Okay, so with that aside, let's go ahead and now discuss the Pikachu class. So, Pikachu is going to inherit from Pokemon, and it's going to be a private inheritance from Pokemon. So, look at our Pokemon class. Everything in this class is going to get copied into Pikachu automatically. Just remember, it's a private inheritance, so these public members from Pokemon are going to be copied and will appear as private members in Pikachu. So just be aware of that. And of course, these private members we have in Pokemon cannot be directly accessed in Pikachu, but of course, we luckily have these public functions that we inherited, and these functions can access those private members indirectly. So, in our Pikachu class, we have our two constructors. I wrote these two for you in a header file. Well, basically, for a default constructor, we're going to call the Pokemon default constructor, and we're going to assign the random function, a random object seed to be 0. So we also have a private variable rand_random in this class because we're going to be using this object random. We're going to be doing random.get, what's the name of that function again? Random.generate random number. We're going to use this function quite a bit when we're sort of simulating attacking an opponent. So we have this object right here, and this constructor sets the seed to be 0. Now our other constructor, we pass in HP, defense, and seed, and we're going to set the Pokemon, we're going to set Pikachu's HP and defense to be these two values. Remember, we can't directly access HP and defense in Pikachu class, but luckily the Pokemon constructor we inherited can set those two for us. Then we're going to, of course, set the seed of this random number generator object. And then that's our two constructors right there. Pretty simple. Now, for the add move function, well, we call add move and we pass in some move object. Remember, we want to insert this object into the moves array, but there is no moves array in Pikachu. But remember, it's super hidden. So from Pokemon, we can just call that Pokemon's add move function within Pikachu's add move function. Same thing with decrement HP. That can also, same idea, we can call Pokemon's decrement HP because remember, we can't directly access those fields. And then same thing for our int get defense and int get HP, same thing. We can't directly retrieve them, but luckily we inherited those functions from Pokemon class, get defense and get HP. And then for display HUD, this one's rather simple. All you have to do is see out the string Pikachu. So it's given here in a PDF to see out Pikachu. And then you want to call Pokemon classes display HUD. And that Pokemon display HUD will display all, you're going to call this function in that function body, which will go ahead and display all that stuff. So you simply have to see out Pikachu and then call the base classes display HUD function. Let's go ahead and now discuss, this is a more challenging function, which will be the attackPikachu. Let's go ahead and discuss this function in detail. Okay, so for the attackPikachu function, this function is going to take in a reference to the opponent Pikachu object and then the move index you want to apply on this opponent. So the first thing you have to do is verify if this move, so the move at the move index can be applied. So remember, either this index out of bounds, or let's say we've already used up all of those moves. So let's say for Pikachu, we have, let's say, the shock move, and it only can be used 5 times, and we use it 5 times already. So then we can't use this move ever again. We can't use it anymore in this particular duel. So we have to verify that the move index, so moves at move index on amount, has to be bigger than 0. If it's not, that means you have to return the character U back to main. That tells it that this move, for whatever reason, couldn't be applied. Either it was out of bounds move index, or because that particular move had the amount of 0, which means we maxed out the amount of times you can use that move in this particular match. Now, this moves array, we can't directly just say moves at index move index dot amount. We can't do that because remember, moves is a private member in the Pokemon class. But luckily, in the Pokemon class, there are some getters that we can use to help us out with this. I'll leave that open, but just letting you know, we do have some getters in Pokemon that will help us out to help us determine if the amount is above 0 or not. So let's say, for example, that now the amount is above 0. We don't return the character U. We have to now verify if this move is going to land on the opponent or it's going to miss. So we have to, of course, retrieve the attack from the move array. But of course, again, we'd have to find a way to, how do we get the actual move object? Well, we can't just say moves at move index dot power, because once again, that's a private member. But there is a getter function in the Pokemon class that if you pass in the move index, it returns the attack move. And of course, if you have the attack move object, you can easily get the power, accuracy, and so forth out of it. Okay, so now what happens, you have to be able to determine, based on the accuracy, will this move actually land on the opponent? Now, the simplest way to do this is we're going to go ahead and just take our random object, a random number object, so random dot generate random number, mod it by 100, it will give us something between 0 and 99. Now, given our accuracy, we have to compare this value to our accuracy of that move to determine if this move will land or not. I'm going to leave this sort of open, but the idea is if I have, let's say, 20 as my accuracy, and I do random dot generate a number mod it by 100, well, if it's in a particular range with respect to the accuracy, let's say in this case of 20, if it's in a certain range, we'll say that this move will hit. If it's not in that range with respect to the accuracy, we mark it as a miss. I'm not going to give it away, but it's not that hard. So just think about it a little bit. So you first verify if the move will land. So let's say the random dot generate number mod by 100, and then it's not in a particular range with respect to the accuracy, that means, okay, this move in this case will say misses. So we have to return the value n. But we have to still decrement the amount of that move because we still applied that move on the Pokemon. Unfortunately, it missed, but we still did use that move. So we have to decrement the amount of that moves at the move index. And of course, in Pokemon class, there is a function to, let's see, where is it? Move used. This function right here decrements the amount of the moves array at index, whatever we pass into this function. So this int is an index value, and it's going to decrement the move at this index. Decrements the amount of that attack move object. So we do that, then return m, meaning that, well, this attack missed, but we still have to decrement the amount by 1. And now for the final part of the logic, so let's say our number modded by 100 is within a range with respect to the accuracy of the move, then this move is going to hit. We have to decrement the amount of HP from the opponent. And then we have to return H, implying a hit. So basically, here's an example I gave you in this PDF. So suppose we use an attack that has a power of 10. So it's going to inflict 10 units of damage on the opponent. But the opponent has a defense of 25%. Then we take 10 minus 25%, which is going to give us 7.5, we'll typecast 7, and want to decrement the opponent's health by 7, not by 10, because the defense is 25. So the defense is a value. It's not a decimal, it's an integer 25. So you have to get the percentage from the integer 25, which I'll let you figure that out. So of course, you can extract the opponent's defense value of 25, subtract that percentage from the power, and then subtract that amount from the opponent's HP, which of course you have the function decrement HP, which is a member function of the Pikachu class. You're going to pass in 7 in this case, which will decrement the opponent's HP by 7. So that's like the more, I guess the more busier function in a way in this Pikachu class. Let's go ahead and now discuss our main and our input. Also, just to go over how the program runs. So we're going to use Linux redirection to feed in the user input. And we want to, of course, I want to mention that here in this video as well. Let's go ahead and first go over the main, and then I'll go over how to run this program. Okay, so for the contents of main, well, the first you want to do is we're going to have to read in 2 Pikachu files that's going to simply contain all of the data to be able to create the objects. So we're going to pass in the file names through a command line argument, but don't worry, it's not going to be anything too complicated. We're going to have just simply 2 file names on the command line. So remember, for int main, we have int args, and then char star argv. Well, actually, char star almost sounds like Charizard, so I guess that's a happy accident. It does make sense. It does go with the theme of the assignment, except Pikachu, but you know, Charizard was also a famous Pokemon character as well. So anyway, back to this. So we have argv1 will be our first file name, which will be just pikachu01.txt, and argv2 will be pikachu02.txt. So we create 2 input file stream variables, and we're going to read these files to be able to create our 2 Pikachu objects. So input file, file1, sorry, will read this file right here, and each file contains the following. The first line will give us sort of the defense amount for Pikachu, and then the number 33 will be essentially the seed for Pikachu 1's random number generator. So defense and seed, and then we simply use a constructor to create the Pikachu object, and then we have 4 lines of input. Each line contains a move data. So we have the name, then 25, the next number tells us the amount of times this move can be used. The next number is the power, the damage this move can inflict. And then the last number is the accuracy. So same idea. Next line, thunder, only 5 of them. And I guess 25 is a pretty powerful move, although I don't think it's too powerful against Pikachu, but you know what, we'll just use make-believe numbers. So we have thunder as 5 of them we can use in one battle, and we have a damage of 25 and a 70% accuracy. And then same thing for slam and punch. Pikachu 2, same idea. For this Pikachu, we have defense is 50, and then 22 is going to be assigned to the random number generator object's seed. And then we have these 4 moves over here as well. So there we are. So we simply have to first create the Pikachu objects using these 2 fields. Then we have to call the add moves function 4 times for each element of these files. So now that we create our 2 Pikachu objects and we add the moves into each Pikachu object, now we can simulate this battle between 2 Pikachus. So I gave you this kind of this step-by-step process. You can see here that this step 1 will be kind of a while loop of some kind. We first verify if both Pikachus have a health larger than 0, we enter this. Otherwise, we go to step 8, which is really going to be outside of the block of the loop. So steps 1 through 7 is a loop, and step 8 is really outside of the loop where we just simply output the winner of this battle. So we first want to output for player X, so player 1 or 2. So we're going to first start with player 1, clearly. We're going to have player 1 starts first, output player 1. We call it display HUD. We ask for a move index, and then we call player X's attack Pikachu function, and we're going to pass in, well, I guess I said P2 or Pikachu 2, but really we're going to pass in the other Pikachu object is what I meant to say. So if we have player X, we want to pass in player Y, the Pikachu Y, the other Pikachu object we want to pass in. So I have mine as P1 and P2 in my program, so I would say P1.attack Pikachu and pass in P2. If I'm calling P2s, well, anyway, I don't want to stumble too much. Let's go ahead and just get to this. So we call player X's attack Pikachu function. We pass in the other Pikachu object and the index red at step 3 into the attack Pikachu function. Now, if it returns the character U, we output move not available, and we jump back to step 1. So we kind of restart the loop because, well, this means the move wasn't we couldn't make a move right there. So we're gonna give them another chance, essentially. And then okay, or let's say if it's not U, let's say this function returns the character M for miss. We output attacked miss. Then we want to alternate X from 1 to 2 or 2 to 1, and then jump back to step 1 and then do the same thing but for the other Pikachu character this time. We're going to simulate the other Pikachu opponent's turn. Now, if let's say it returns an age, we output attack hit, and same idea, alternate from 1 to 2 or 2 to 1, go right to step 1. So we keep doing this every single time. All we do is simply output the Pikachu, whichever player we on, 1 or 2, we output that Pikachu's health and moves. We ask for an index. We apply the move on the Pikachu. And if the move was a hit or a miss, either way, we were able to make a move. We alternate, jump back to the top, and keep doing this until we finally have the game over. That's the idea. So let's go ahead and now talk about sort of running this program. So we're going to actually use Linux redirection to feed in the input. And the reason why is because, well, that's what CodeGrade does actually too. So you want to try to understand how that works. I will actually on terminal here show you this so you'll be able to understand what I mean by this. Let's go ahead and now just go into the sample run and go over how to actually run this program. Okay, so here's our sample run. I actually have 4 different runs I use in my program. And in CodeGrade, I'm going to use those same 4 input-output test runs. I actually will provide you with the txt input and output files in the Canvas assignment post. But I want to put at least 1 right here in the PDF. But to limit the number of pages, I don't want to put all of them into 1 PDF. So right here, I compile my code without a makefile, but we don't have too many files to work with, so we'll just keep it simple. So I have my main, Pokemon, and Pikachu. I'm going to run my program, start a.out. Here's my Pikachu 1, argv1, argv2, and this is the bizarre part. So you might not have been exposed to this in 135, but I'll mention it right here. This is going to be a Linux redirection. So all the input is going to be fed in, not through us typing it out, but right here we can see here's the input, enter move index, we enter value 1. These values of 1, I didn't actually type these. These are automatically fed into the program. Let's see how this actually works. So first, I'm going to go ahead and just simply show you how this program runs, just normal. So I'm going to first compile everything. So main.cpp, I'll have Pokemon.cpp, and then Pikachu.cpp. There we are. Let's run this. I'm going to go ahead and pass in Pikachu01.txt and then Pikachu02.txt. It's actually supposed to be on 1 line, but the file directory is kind of long, so it kind of wraps the next line. This is all in one line though. And there's my inputs so far. So Pikachu for player 1, Pikachu, health is 50. So remember, the Pikachu objects get HUD outputs Pikachu, and then this is going to be, it outputs the string Pikachu, and then this is just the Pokemon classes get HUD function outputs the rest. Okay, so I'm going to enter a value of 1. So I'm going to go ahead and apply Growl on my opponent. Of course, the attack hit because 100% accuracy will hit it for sure. And we see we reduce the HP by a little bit and so forth. So, I can, of course, test out the inputs. I'll try once. I'll use Shock. So player 2, I'm going to apply Shock on player 1, which will land because it has 100% accuracy. And we can see that actually took a little bit of energy out of the first Pikachu. So we have 43 health and so forth. So of course we can enter movement indices in, and we'll just keep on applying these one by one. Now remember, I display it 1 through 4, but we have it as 0 through 3. So a very simple offset you have to do to sort of shift the index to, between 0 and 3. Not a very complicated task. So just make sure you're aware of that. Okay. So of course, there's a lot of inputs in this program. So we could, of course, every single time type all these out every time. And believe me, you may have to do this more than one times. And it's going to get, really, how shall we say, a pain in the neck, I think is the right word to use right now, because we don't want to keep typing this out every single time. So let's go ahead and be able to apply this Linux redirection, which will allow us to just feed all the input in at one time instead of having to have us type this out step by step. So let me go ahead and show you input01.txt. So I have it here on my just open up Notepad++. Okay, so here's the actual file I provided. Sorry, my mouse is a little bit messed up on my computer, so it double clicks, my single clicks sometimes. So here's our file. So we're going to feed in 1, 1, 2, 4, and so forth. So, of course, we can type these out every single time, but I don't want to always do that because that gets a little bit annoying. So I provided with you a set of input files you can use to feed in. So CN will read from this file and not from my terminal. So I go back to my terminal for a second. See over here, when when I have my program set up, I'm running it like this. It's going to simply ask me, I have to give it natural numbers. Okay, you have to enter number and so forth. So with redirection, how that works, it's fairly simple. We just simply have our a.out, our 2 input files. I'm going to use this symbol that looks like it's having an arrow that's pointing towards a.out, and type in input01.txt. So now what's going to happen is everything that CN reads is going to read from this file and not from me typing it in. Let's test this out. Oh, that's pretty cool. It just ran through all the input at once. Now, I guess here's one issue with this. Let's scroll up here for a second at the very beginning, just because. Look at this. Enter, move, index, and is it supposed to be number 1 right there? Because our input file contains the value, the first number is a 1, right? So that's not right. How come it doesn't display that there? And the reason why is because, well, we didn't actually type that. It automatically read that from the file. So that's good, but the problem is I really want to display the inputs right here because on CodeGrade I have it set up where it will display these. And what's good is that if you have the actual inputs display here, it makes it easier for you to see which input caused. If let's say you're trying to debug your program, you want to know which input is what caused the error to happen or so forth. Also on CodeGrade, you can see which input caused some mismatch in the output. So to fix this, I'm not going to show you my code, but what you can do is when you have your CN, you read in your index. You can just simply output that index read in. So in my code, which I'm not going to show you, I'm just going to simply just output what I read in right here. Let's see what happens this time. I modified my code. I'm going to go ahead and recompile. Recompile this guy. Let's run this again. And now we can see that I just simply, whenever I read from cin, I just output immediately. So now I'm actually going to display the input that my program read. So now we can see what input was read on what line, and you have to type in this input every single time. So it makes it a bit easier to test your program. Now you may wonder, what if I actually keep this cout after cin in my code and I don't use a Linux redirection? Well, I'm glad you asked. Here's how you would do that. We go ahead and just run this again, but I'm not going to redirect. I'm going to enter 1. So notice this. I read in 1, but I output the 1 right here as well. So this right here was me typing in 1 enter, and this is my program output that. So really, I guess it makes the output when you do interactively, it's not so nice, but you know what, it's not a big issue. If I type in 4 over here, it just re-outputs at 4. Not a big problem, but at least now, when you run this in the redirection mode, it will display this 4 to the terminal, so it will be easier to see on code grade what input created what output, and also for yourself as well. So I guess for your assignment, all you have to do is submit a main.cpp, which will be your main game, submit pokemon.cpp, and submit pikachu.cpp. All the input files are provided on CodeGrade, and the header files are also going to be on CodeGrade. Those will get linked automatically to your implementation file. And also, I will provide you with all these input files, the header files, and I will also provide you with skeleton implementation files and a skeleton main file as well in the assignment. So I guess happy coding. Hopefully this video did help, and till next time.